spend a lot of time looking at the reviewing of factoring rules in this particular section 4.3. First up, we have what's called a simple trinomial. Simple trinomial is where your A term is 1. You're looking for numbers that will multiply to give you the back, to add up to give you the middle term, the B term. We have the difference of two perfect squares, A squared minus B squared, factors into A plus B, A minus B. We have a perfect square trinomial. Term in the front is a perfect square, term in the back is also a perfect square. Those two pieces multiplied together doubled gives you the piece in the middle. If that happens, you can write it as A plus B quantity squared, and we'll look at samples for each of these. All right, let's start with the simple trinomials. X squared plus 7x plus 12. You should be thinking right away, two numbers that multiply together to give you 12, add up to give you 7. Hopefully you're coming up with 3 and 4. Two numbers that multiply to give you 20, add up to give you a negative 9. Both of your terms this time are either going to have to be plus plus or both minus minus. Since they have to add up to give you a negative 9, we're going to need both minus and minus for these. X, and then your two numbers, 5 and 4. X squared plus 5x minus 9. You're trying to look for numbers that are going to multiply together to give you negative 9. 9 and 1, 3 and 3. Are any of those going to multiply together to give you, or add together to give you a 5? Hopefully you're coming up with no. And if that is the case, we call these prime. You will have a couple of those sneaky ones that will show up in your homework. Answers are prime. Difference of two squares. These are the ones that will be A plus B or A minus B. Plus 9, minus 9. It does not make any difference which order you put those in. X minus 9, X plus 9, that's okay. X squared plus 25, the one that you need to watch for here. You can never ever factor the sum of squares. They throw one of these in periodically, mixed in with all of the negative numbered ones like these. Can never do these. This again is prime. Factoring a perfect square trinomial. So here's where we want to look to see if the number in the front is perfect, the number in the back is perfect. X squared, yes, 49 would be 7 and 7. X squared comes from x, 49 comes from 7. So here's where you want to do the little perfect square trick. If you multiply these two things together, x times 7, double that, do you get 14? If your answer is yes, then these are the terms that you will need to create this perfect square trinomial. X plus 7 squared. This is also just plain x plus 7 written twice. So if you miss the fact that this could be a perfect square trinomial, then hopefully you still were able to figure out two numbers multiply together to give you 49 and to give you 14 would be 7 and 7. Well, this can just get shortcut and written as x plus 7 squared. X squared minus 24x plus 144. Perfect square on the x squared. 144 is a perfect square, 12. Can I multiply these two together and double them to get a 24? Yes, which means this one will be x minus 12 squared. Why the minus sign? This one started with a minus sign in the middle. Whatever sign you have in the middle is the sign you're going to have in your middle. Roots of an equation are called zeros. This is the place where your curve crosses the x-axis. That term, roots or zeros or solutions or intercepts, every single one of these words is interchangeable. So you'll hear me mention these words all the time. If you're looking for solutions to equation, you're looking to the zeros to an equation, you're looking to find the roots or the intercepts. They all mean the same thing. How do we find these solutions? We factor the equation first, and then we solve each piece by setting it equal to 0. When you do that, that is called the zero product property. First one here, x squared minus x minus 42. You're looking to factor two numbers that multiply together to give you negative 42 that will add up to give you negative 1. x minus 7, x plus 6 equals 0. So now here's where we solve each piece. Take each of these out, set them equal to 0. This is the zero product property. Take each product of x minus 7, x plus 6, take each of those products out, set them equal to 0. You don't need the parentheses on that actually, we'll just take those off. Take each of these products out, set them equal to 0, and solve. This is called the zero product property. Add your 7 on both sides, subtract your 6 on both sides. That is how you find the solutions to an equation. These would be the two spots where this curve crosses the x-axis, crosses at 7, crosses at negative 6. X squared minus 4x plus 4, same thing. X minus 2 and an x minus 2. Two numbers multiplying together to give you a positive 4, add to give you a negative 4. Notice how these two are the same thing. This is a perfect square trinomial. Could also be written as x minus 2 squared equals 0. But remember, we're looking for solutions, so we take each solution out, set them equal to 0. Well, the solutions are the same when you take them out, so we only need to take it out one time and solve, and x equals 2. When you get an answer that is the same thing twice, we get each of these same answers, this one is 2, this one is 2. This is called a double root. Double root when you get the same result twice in an equation. Word problem that goes with this could be like this one. A garden is 15 feet by 10 feet wide. I want to double the area by adding the same distance x to both the length and the width. Find the new dimensions of the garden. Well, it always helps to draw yourself a picture to start with. So we've got a rectangular garden, 15 feet by 10 feet. I can use length times width to get the area of this original garden, 150. So what am I trying to do? I'm trying to double that area. Well, if the original area was 150, when I double it, that means this area is going to be 300. How am I going to get that new area? I have to add the same distance x to both the length and width of the original. Well, my original length was 15. I need to add x onto that. My original width was 10. I need to add x onto that. Now I can set up an area formula, length times width, 15 plus x times 10 plus x, and set that equal to my new doubled area of 300. All right, so now we want to try to solve this equation. Well, if we do our FOIL, and if you need to, you can change these around, so it says x plus 15, x plus 10, it doesn't make any difference. 150 plus 15x plus 10x plus x squared equals 300. X squared, like terms, are 15x plus 10x. 150 is on this side. I need to subtract 300. Gives me negative 150 equals 0. Now I need to try to factor that. Two numbers that will multiply to give me negative 150 that will add up to give me 25. If I choose 30 and 5, those two numbers multiply to give me 150. I need to have a negative 150, and when I add them together, I need positive 25. So the bigger number, 30, takes the sign. Negative on the 5 equals 0. And now I use my solving property, zero product property. Take each one of these out and solve. Subtracting 30, I'm going to get x equals negative 30. Adding 5, I'll get x equals 5. Those are my two possible solutions. Well, now we have to go back in and see if these make sense. Anytime you have word problems, you need to go back in and see if they make sense. If I take negative 30 and put it back up here in place of x, and try to get a new width out of that, 10 subtract 30 is negative 20. Can't have a negative distance, so negative 30 is out in terms of one of my solutions. If I take 5 back up here and put in a 5, 10 plus 5, 15, 15 plus 5, 20. So 20 by 15, will that work to give me my solutions? Twenty times 15 does give you your 300 for your new area, so that means x. Find the new dimensions of the garden. My adding number will be 5, and my new dimensions are 20 by 15. That should do it for practicing with your factoring. So some of the same old factoring techniques that we've learned long time ago, and then how you can use those factoring techniques in a word problem like this one. All right, you are ready to go with this first half. And reminder, this is just the first half of section 4.3, day 1.